Hi everyone, I am Ranjita Via, currently pursuing MC at Marian College Kottikanam Autonomous. Today, I am here to present about the deadlock detection using wait for graph. It is a graph theory application in operating system. Now, without further delay, let us start with this presentation. Now, let us check what is deadlock. Deadlock is a condition where two or more processes wait indefinitely for each other. Each process holds a resource required by another process. No process can proceed with execution. The system may freeze or its performance may degrade. It is a commonly occurrence in the multi-processor system with shared resources. Shared resources in system, they are memory, that is RAM. It is used in the multiple processes. CPU time, that is shared through scheduling. Disk input outputs, that is used for files and database access. Logs, that is ensures safe exclusive access to data. Devices, that is a hardware like printers shared by processes. Now, let us check what is the wait for graph. A wait for graph is a directed graph that models waiting relation between the processes. That here, nodes are represented with the processes, that is the process P1, P2, P3, etc. These are the processes that is represented by the nodes, and the edges that the process P1 and P2, they are connected by an arrow or any other connection. This connection is called the edges. Here P1 and P1 is directed to P2, means P1 is waiting for the P2 to release a resources. This is a simple example for no deadlock. There are three processes, that is process P1, P2 and P3. The process P1 wait for process P2. The process P2 wait for process P3. When the process P3 completes, the chain resolved. There is no deadlock happens here. Now let us go to a case study that the three process deadlock. Coming to the scenario that there are three processes, that is process P1, P2 and P3. P1 hold resource A and wants resource B, and P2 holds resource B and also needs the resource C. The P3 hold resources C and wants the resource A. Here, all these processes are blocked indefinitely. Deadlock detection algorithm. Create a node for each active processes. Add a process P1 directed to P2. If a P1 is waiting for a resource that is held by P2, remove the edges when the resource is released. Periodically check the graph for cycle. If a cycle is found, then a deadlock exists. Cycle detection method. The different cycle detection methods, the first one is DFS, that is depth first search. It is one of the fastest method to find the cycle. Next is the time complexity. The time complexity is that it depends on the number of edges and the vertices that find in a graph. Commonly used to detect the deadlock. Next is the union find algorithm. It is effective in the undirected graph and not suitable for the directed wait for graph. Next one is the color-based marking, that is help to track nodes, traversal and detect cycles during DFS. Uses white, gray and black colors. Now let us check the real-world example, that is Linux kernel. The modern Linux kernel uses the resource allocation graph. Internally, the median process dependency information in the Linux kernel memory periodically convert this message into a wait for graph. Users optimize the DFS to check the graph for cycles. If a deadlock is detected, the warnings are logged in system logs. What happened when the deadlock detected? The kernel selects victim process based on priority or the cost. Forcefully terminate or roll back victims. Release resources held by victim. The other process resume execution. The system logging for analysis. Deadlock recovery strategies. There are different deadlock recovery strategies. Now let us check what are the recovery strategies. First one, that is the process termination. In this method, one or more process involved in the deadlock are terminated. The system Select a victim process based on the factors such as priority, execution time, and the resource usage. Terminating the process immediately release all the resources held by it. The others wait processes can then continue execution. This method is simple but may lead to loss of work or data. The second recovery strategy is that resource preemption. Here, the resources are forcefully taken from one process and given to another. The system temporarily preempts resources from low priority or less critical processes. The preempted process is moved to a wait state until the resources are reassigned. Care must be taken and avoid starvation, where a process never regains resources. This approach is effective but complex to implement safely. The third recovery strategy is the process rollback. The method uses checkpoints to recover from deadlocks. This method periodically saves the state of processes. When a rollback occurs, the affected process is rollback to its last save checkpoint. After rollback, the process is restarted with fewer or different resources. This method is reliable but required additional memory or and overhead for maintenance checkpoint. Victim selection criteria. The operating system chooses the victim based on the process priority level, execution time completed so far, resources already allocated, the resources still needed, the number of processes affected by rollback. Advantage of wait for graph. That is, it is simple and visual. That is easy to understand and debug. Fast detection. That is, cycles are detected using time complexity. Low overhead. That is effective for many processes. Then practical, used in Linux databases and cloud system. Then it is also reliable. That is, detect all deadlock cycles. The real-world applications, that is, it is used in the operating systems such as Linux, Windows, Unix. The database is used in the MySQL, Oracle, PostgreSQL. It is used then in the distributed systems such as cloud platforms, microservers, and the concurrent controls such as transaction management. It is used. The limitations of the wait for graph works only with one instance for each resources, not suitable for multiple instances. Then it is needed regular checkings causing some overheads. Recovery may causes loss of processes or data. Wait for graph versus resource allocation graph. The resource allocation graph, that the nodes are represented the processes and the resources. The edges shows request and allocation of resources. Now coming to the wait for graph, the nodes are represented only the processes. The edges show which process is waiting for another. The simpler and mainly used for the deadlock detection. Now, coming to the conclusion that the wait for graph is a simple and effective technique for detecting deadlocks in operating system. By representing the process dependencies as a directed graph and identifying cycles, the system may reliable determining deadlock situation. Its low overhead and clear structure make it widely used in practical systems such as operating system and the databases. Thanks for listening. Hope you found helpful and informative.